All right, so I'm back. It's currently day 39. I have to update this. Let's go ahead and update the local repository. And here we go. So it's day 39. Today I'm going to be debugging the model training in my TFX model ML project, ML pipeline project. So today what I'm going to be doing is figuring out how the TFX IMDb example works in TensorFlow, the TensorFlow tutorial, and the TensorFlow tutorial works. Then understanding how to use the custom TFX components which is used in the tutorial, and finally trying to understand the pre-processing required for the model using the MDB dataset. So I guess today is just mostly reading up and figuring out how to pre-process the data and kind of just debugging where my mistakes are. I'm not sure if I'm going to be able to find and implement the changes today itself, or if I'm going to be pushing that the implementation of the new fixes to tomorrow. We'll see at the end of the stream. So first things first, TFX IMDb tutorial. Is this the one? I don't think so. So I think what it was called was NSL, Natural Structured Learning. IMDb. Where is it? Yeah. Oh, it's neural structured learning, not natural. Okay, so neural structured learning. What exactly is neural structured learning? New learning paradigm to train neural networks by leveraging structured signals in addition to feature inputs. Structure can be explicit as represented by a graph or implicit induced by adversarial perturbation. Huh. Amount of labeled data is very small. Harnesses both labeled and unlabeled data. Interesting, interesting. Okay, so I mean, all of this is okay. It's great, but the only thing is I have to figure out if, for example, let's see. So they have this transform and they have a custom graph regularized trainer. So I believe this new structure is not going to be compatible with a regular neural network. I'll have to check it out. So text, TF hub to embeddings, embeddings to then synthesized graph. That's what they're doing here with the synthesized graph. They're in graph augmentation, which then feeds to regularized trainer. Let's take a look at the transform component again. The results include an input TensorFlow graph used both in training and serving pre-processing data. This graph becomes a part of the saved model. Pre-processing always will be the same and needs to be written only once. Okay, cool. Requires more code than the other components. ID, node ID of sample, text underscore xf, list containing word IDs, and label xf. We define sequence length, vocab size, OV. Start off with tokenized reviews. Lowercase, then we replace all of these symbols. We split. I'm not sure what that is. What's that doing here? I think we add start and end. We're tokenizing here, so we're splitting every single word, I believe, till sequence length. Tokens to tensor. What's TF pad? Pad's a tensor. Then we reshape. Pre-processing, we have outputs dictionary. For outputs ID, we have inputs ID. For me, ID is name something else. And then we tokenize the reviews. He doesn't use a loop anywhere here. That's because I think his constants isn't really a list. Okay, let's go back to text classifier, ML, then it's the models, pre-processing.py. And let's take a look at the constants, or I mean the features. So features here, features key, I believe I could just use it as, but I don't know where features keys are like used, so I'm gonna leave it like this. So I'll have to do it in this loop, even though this loop is running only once. So for text standardization, I'm going to be adding this. So it's going to pass in reviews and sequence as sequence length. Did I ever use constants in here? I didn't. Well, now I'm going to need to because of the fact that I'll be using all of this. Vocab size, sequence length is already defined. So I'll get rid of this then. Well, I feel like max features and vocab size is the same thing, but I'll just keep another one. Okay, so text standardization. I have input data, which is text, which is reviews. I'll call this reviews. And then I have sequence length, which will be constants dot sequence length. Returning text. Well, actually, I'm not really returning text, am I? So I'll get rid of this. I'll be returning tensor. So let's see. Lowercase, same thing. Instead of input data, I'm calling it reviews. And then all the rest of this reviews. Call this lowercase. Add a couple more lines of regex and all of this stuff. You can just copy paste. Tab that correctly. Let's get rid of this. Save that. All right, next up, changing the pre-processing function. So output stays the same. For my ID just means the label key, I believe. Oh no, hold up. Well, what is ID here? Is ID an integer value which indicates I think so. But I don't think we have IDs, so I'm going to skip that. So tokenize reviews, tokens, tokenize reviews, inputs, text. And then it uses outputs, text underscore xf, apply and compute and apply vocabulary. It passes in tokens, top K. Okay. Oh, I see. So here for tokens, I'm passing in this. So for tokens, let me pass in text standardization. Well, I guess it's the same thing. Where is fill in missing values? Over here. So I'll have to add in this new function. To fill in missing values of the inputs, and then it'll be key, so I'll have to put it in here. And then fill in with empty string. It fills in values of x with default value, which is just empty string. Returns a rank 1 tensor where missing values have been filled in. Okay, next up, what I'm going to be using is a tokens here. And I'll be specifying top K. So this print is not even going to work, so it doesn't really matter. And then finally outputs, the label, I'm going to also be passing in fill in missing values, -1. It shouldn't really matter because the data set I got is from Kaggle, and they listed even when we do print out like the statistics, we can see that there's no -1 value, so there's no missing values. Regardless, we'll just shape it properly. So the data set, the data structure will be the same. Okay, next, it's calling the component. I'm going to purge the TFX output file and TFX metadata. I guess I'll leave it. So next up, graph augmentation. I think I'm going to skip on this and check out the trainer component instead. So let's go to models, model.py. NSL, I want to see where they're using NSL. Hyperparameters. They're using it for distance type. Graph configs. Does it ever affect? So they do hyperparameters dot train files. Hyperparameters. Pass in hyperparameters in schema. Trainer component. Trainer function. Did I ever use model.fit? Just interesting. Let me just take a look at the structure for the model and then see if I can use it. So they use the feed forward. Embeddings function returns the embeddings of the corresponding features. A dictionary containing batch features returned from input function. Builds computation graph. This is not a regular Keras model. Definitely not a regular Keras model. I don't think this is going to be any help. Now I just have to trust that the changes made to the preprocessing function can just be fed into my model.py. Let's see. I'm using the embeddings with max features and embedding dimension set to 16, I believe. But I never performed like embeddings. Only if I could like take a look at the outputs from this preprocessing function, everything would make sense for me because I'm not really sure what this is outputting and how exactly that's feeding into model.py. Like where is this train data set coming from? It says input function. And then we pass in the schema data accessor. Let me take a look at their schema. Oh, it's direct. So statistics gen. Use file names, TensorFlow transform output is training and batch size. So TensorFlow transform output, where am I getting that from? Input function, where is this being called? Over here. fn.args. It's being passed from the local runner. Train files. So let's take a look here. Create pipeline. Maybe it's actually in pipeline.py. So trainer, run function, sample gen dot outputs, train args and evaluation args. Must be passed from run function then. Wait, what? Comes from fnrx. Where do I specify fnrx? Starting to get a little confused here where exactly the files are coming from. And what exactly are these trained? Like, where are these files coming from? Passing information to UDF. Accessing data on disk. Args pass to user-defined training and tuning functions. Okay, let's try this. Not sure if it's gonna work, but I wonder if the changes to preprocessing.py might make a difference. Go building pipeline, text classifier. Now I'm going to run it. Now I'll be able to see the outputs generated sequentially. Error occurred. It's the same error. Nothing changed. Still an issue here. So hard to debug this. I don't understand. Like where cast string to float is not supported. It's path sequences imported from Keras preprocessing. I guess I'm doing that in preprocessing, right? I mean, here with the pad. He's using tokenizer from Keras. There's something that's going wrong, like right here. And for some reason, it's the input that's being fed into the trainer function is a string. Let me check if the yeah, okay, wow. Okay, see here, the transformer component didn't even run. So there's something wrong there. Like it just straight up got skipped. Let me check pipeline.py and make sure it's added to components. Looks right to me. Passing in components here. And in components, I'm appending transform. So why didn't it run transform? So here's schema gen is completed. Next up would be statistics. Schema against computer statistics, done. Okay, so example validator is done here. And next up, it just straight up goes to the trainer component. Okay, TFX not running. How about this? Let me just not append trainer. Let's delete all of these outputs. Did that not work? We have to delete the whole directory. Why isn't it working? Delete. Yes, delete. There's no trash bin. Permanently delete. Yes. Gotta remove recursively. -r tfx pipeline output. There we go. Got rid of that. So now let's run it. An error occurred. It did end up running transform. Oh, but a value error occurred. So my transform component is running into errors. Okay, but where is this error coming from? There's a couple of errors happening. Shaper. There's a typer. There's another type error and a shaper. I mean a value error. Expected string got tf ragged tensor. Where is it expecting a string? v2 string not convertible to tensor string. Line 61 in preprocessing, line 38 in text standardization. So tf concat. Something's wrong with tf concatenation. And I believe it might be because of this. String not convertible to tensor and then string. So tokens not convertible to tensor. Okay, that narrows down things. Something's wrong with line 38. I mean, comes up till here. Tokens is not in the right format. It's not a string, but it should be a string. Sequence length, constant of sequence length. I don't think that has an issue loading in. Returns a ragged tensor. So expected string got a tf_rag tensor. That's what's happening here. TensorFlow 2.5 says that tf.strings.split returns a ragged tensor. I mean, it's the same thing in this example as well. Like tokens isn't really changed after this, so shouldn't it be, or should this be a rag tensor as well? What does this return? A tf.tensor with shape, dimensions, and the same data type as value. So if start tokens same shape as values, which is reviews, and reviews is a string for me, but what is it for them? It'd be inputs text, which should be what? Bytes, which is a string. So why am I getting different outputs? Input has to be a tensor or a sparse tensor. Well, tf strings regex replace, that should return a string tensor. So this returns a string tensor. String tensor is being converted to what is it, TF ragged tensor or something. Then finally, rag tensor is not being able to combine with two-string tensor. So that's the issue here. Expected string, but got a TF rag tensor. And for some reason, TF rag tensor is not convertible to a tensor. Reviews here is passed in as text. What if I just remove this typing? And I let's see, apply tokens, text standardization. Okay, so now reviews is no longer a string. It passes in as a rank 1 tensor. I don't know, does that make a difference? Guess we shall find out. Same error. Not too sure how to change this. All right, I'll just update my log. I don't even know what to do tomorrow. I'm so like discouraged by this. Let's see how I'm doing on challenge goals. Learn about CUDA, deep reinforcement learning, MDPs, be good on Markov chains, and also stationary distributions. Probabilities. Why does that not seem right? MDP, still need to review, learn more about generative learning, AWS microservices. So what I think I'll do is just move on to CUDA. ML pipeline, so TFX. Orchestration tools. Which is Apache Beam and Airflow. Okay, so I think I'll continue just with CUDA to put my mind off of this. Maybe I'll put in a TensorFlow like GitHub issue request or some sort of, I don't know, I'll post this issue somewhere and then hopefully someone on the community can help out. Till then, I'll just continue and not get stuck over this one issue. So I'll get a book for CUDA, start learning about CUDA. So I'll do that tomorrow. This will get me a feel for learning the hardware optimizations for machine learning. And then from day 41, I'll start learning CUDA. And in the meantime, in the backlog, I'll keep this, post an issue on GitHub or Stack Overflow, and then check in later. Right, so guess that'll be it for today. Should I stay tuned now? All right.